we're going to study PixiJS event system. I think I'll do half an hour with a camera and then I'll remove the camera after. I also think I'm gonna do some touch typing, train typing. And I'm gonna do the Italian thing, I think, after half an hour. Yeah, now that I understand a lot more how everything works, I'm going to... I spend a bunch of time trying to understand how it changes everything, but it's still very confusing. Like, the biggest problem I have right now, the biggest challenge is that I don't know a good way to emulate the drag event, because if I put breakpoints through the mouse move event, then it's just gonna break the application before I click. And if I put the breakpoint events through the mouse down, then I'm not really sure if it's gonna capture the whole cycle of putting the mouse down and dragging. And I think if I put the events, the breakpoints here, it also doesn't work because it's not exactly what I want. So I can remove the breakpoints that I have now and then just put these ones here. But I think it also doesn't work very well. So what I want to be able to understand is how exactly is Pixi changing what is exactly being changed. And it's also kind of weird because on Pixi viewport, like I said on the last stream that I did, is that the stuff that it changes here is related to the viewport itself, not related to the classes that are involved with the stage. So when it changes on the wheel event here, when it changes the zoom, it changes the X and Y for the parent, which is the viewport. But that doesn't make any sense to me, like, because there's no, as far as I can tell, like the only point of connection would be through the React DOM, because the viewport is a child of the stage container. So that's gonna be the only place that it connects both of them. And I think it might be the case that this is the reason why it works, is because React Pixi uses a custom reconciler, and then on the custom reconciler they call the add function, the add child function. So anything that you put inside of the stage component that I'm declaring here is gonna be, React is gonna call the add child for that component. So when it does that, it's gonna append this to the stage. So I think that's what's happening under the hood, is that Pixi viewport is a container class because it extends the container class, which extends the display object class. And then React calls the add child from the custom reconciler of React Pixi at some point and adds the container to the app stage, which is the main component that I have here. I think that's what's happening. And then because of that, through the event system of Pixi, it changes the values because they are connected that way. But it's very confusing to understand. Because then, I don't know, because when you trigger the wheel event or the drag event, it does change the view. But then since it's changing the container from Pixi viewport, I don't understand how that's... Like, what is the stuff that is gonna be... Like, if it's gonna change everything when it changes the container of Pixi viewport, or if it's only gonna change that container. It obviously makes more sense that it changes everything, so yeah, because... Like, otherwise how would it work? It wouldn't make sense, I think. So I think the logic happens inside of the event system for Pixi. Inside of those functions, the map function on the event boundary, and through those classes, but I don't understand really well how it works. So I have to think about here. And the problem is that with this one, I erased everything that I had from the matter.js, which was using the positions of the which was creating the physics engine and then updating the physics engine, and then I was able to get the positions and the events were actually working. But now it doesn't work because of the stuff that I explained before as well, which is just drawing this and it doesn't have any relationship between X and Y. So there's no effect that happens on this drawing here, regardless of whether or not the event fires. So it's hard to know, like, I think I'm gonna have to maybe go with the other project, because the other project I'm using the PixiJS physics engine, and then I'm gonna have to see, to console log the positions, and then see if after the event gets triggered, it's gonna change the positions or not. But it's kind of difficult to think about what's the best way to go about it. I think I'm just gonna go step through a couple of times, and then maybe next time I'm gonna go to the other project that I have, which I'm still also debating whether or not I should stick with the other project. I created a different project based on Vite, and the issue is that I think that Next.js might have like vendor locking that I don't know really well how to explain how it works, but I think that the way that it works is that they build the framework based on the vendor, which is Vercel. So you might be trapped if you build everything with Next.js. I don't think that's the case right now, but I think that it might be the direction that this is going. So it might be better to move completely to Vite, which is gonna be more difficult, but it's gonna allow me to have more flexibility. So I'm still debating whether or not I should go with that route. And if I do decide to go with the route, then I think I'm gonna just leave this project as a like backup, but then continue to develop on the other one, and then change the Git commits, change the repository, and redeploy everything. It's gonna be pain in the ass. Because the other one I have the most advanced, or most advanced, not the most up-to-date version of the application after changing everything with PixiJS. So I think what I'm gonna do next time is probably to open the other project that I have, and then open with the debugger and try to step over with that project, because then I'm gonna be able to see the positions of the physics engine and the events. The whole thing that I'm trying to achieve here is to be able to synchronize physics engines with the events from Pixie Viewport. I think I'm gonna try to not use Pixie Viewport and emulate the events that Pixie Viewport does, but with my own code, so that I have more control. And so I can synchronize in a better way with the physics engine. I think that the less libraries I'm able to use, the better, but obviously it's inevitable to use some libraries, so because the more libraries you use, you're adding points of failure to the application, like you're adding more dependencies, as the name says, so it becomes more likely that you have problems later as everything updates. I think I'm gonna try to understand the sticker stuff as well, because it's very confusing. I hate linked lists, it's very confusing to me. I don't know why, but maybe it's confusing to everyone. Like this part here fucks up my brain. It's just very annoying to think about what's happening. But I think after explaining on the previous stream, I understand a lot more how it works. Like you have the main ticker class, which is the one that contains the cycle for the animation. And then you have the update function, and then inside of the update function is like, it's creating the, maybe I wish I had done this for the other. I just realized that it would be a good thing to do as I was explaining, but should draw something like this. Like every time you call the add function for the ticker here, it's like you're creating a different listener class here. So when it runs the cycle there for the update, at each cycle of the rendering, the animation, is gonna go over all of the tickers here. It's gonna send the signal to all of them, and then they're gonna run the function for each one. So yeah, it's kind of like they are all connected, but they it's not really a direct connection. And there is something that I have to think about with the other application, because I remember that in the other application, the events are also not working the way that they should, because they're not zooming or moving out. But I think it's just because of the way that the physics engine is set up, because initially I thought that the reason why it wasn't working is because I was using 2 different tickers, but I'm using the same instance of the application to add the tickers. So after like studying all this stuff, I think that that's not the issue there. I think the issue is that I'm not updating the physics engine after the events, but then like it brings the question like of why does it work with Matter.js but it doesn't work with Wrapper.js? Because on Wrapper I wasn't directly changing the physics engine as well, just changing the events. Like, makes more sense to me that the events on Pixie viewport should affect everything that is being rendered inside of the simulation without you having to directly say it, but then it might be different because of the way that the physics engine works, and that's the stuff that I'm trying to clarify. So I need to understand what exactly happens after the event gets triggered. How does it change the... I think that's what I'm gonna do now. I'm gonna try to do this flowcharts, but for the events after the event gets triggered. Just gonna run and skip through all of this stuff here that I already saw. And I realized as well that this future thing, that the thing that uses a proxy there, it might be how the render gets the view, but I think it shouldn't be, like, it doesn't make a lot of sense because that's an attribute, is a value of the attribute. So, but I think it's the same mechanism. Like, the view is not explicitly set on the renderer, but it calls the getView function when you do app.render.view. It triggers the getView function, even though this is not an attribute. So I think it's something like that, but I don't understand really well this part. Why? Like, how does it work? I think I'm just gonna run everything. Yeah, this is the function that I was talking about. So this is the custom reconciler that React Pixie uses. So it modifies the original functions from React and allows you to put your custom logic to determine what's going to happen on the commit phase of the rendering cycle of React. And then here they check to see if the components, which is the parent, has the add-child function, which means that it is a class from Pixie, and if it does, then it's going to add the element to the parent. So in this case, adds the container to the parent, and then it does the same thing for other elements that exist on the hierarchy of components of React. And I think this is the part that connects the stage with the Pixie viewport, with the container class of the Pixie viewport. And then when it changes so it's like, maybe I should draw here. It's like the stage is this, and then the Pixie viewport is this. And then when the event on the Pixie viewport gets triggered, it changes the stuff inside of this one. Not sure if I can... There's a way to put background here, I think. Yeah. So it changes this one, but and because this one is like encapsulating everything that happens on the stage, it changes everything by default because of the way that the Pixie EventSystem works. So when it changes the property of the scale of the container, the Pixie viewport, it directly changes everything else because the events bubble up or bubble down, whatever the order is. I think they bubble up because they get triggered in the most inner part. There is a picture that I saw some time ago on an article. The way that it works is that every time that an event gets triggered on the DOM, is gonna go from the top of the hierarchy up until the element, and then it's gonna bubble up to the top again. Unless you put the stop propagation function, you call the stop propagation, and that's gonna make it so that the event doesn't get triggered on higher levels after it reaches the target. So, and there is some stuff about this propagation, but I didn't spend a lot of time looking. And the other thing that is confusing as well is this emit here, because I don't think that there is any place that is listening to this. I just think that they put this stuff here in case you wanna listen to it, so you can put custom logic, but then it wouldn't make a lot of sense to have them here. But from the event system class, there isn't anything that it is like these events here. And also there is some part of the event systems as well that there's some function that changes the name of the event. So let's say a mouse move event was triggered, it's gonna replace the mouse, I think, for a pointer. So instead of on mouse move, it's gonna be on pointer move. There's a function that does that, but I don't understand really well why it does it. And this is the stuff that I hate about this the Pixie. Like, I understand why they do it like that, it's for flexibility, but it's just very like shitty to work with, because but I guess it's like any other library that is going to use the event emitter, because it becomes very difficult to understand what's happening every time that an event happens, because I think stepping over or stepping into this stuff also doesn't allow you to see like what is going on after you emit the event. Or maybe it does, and maybe nothing is happening when you step into, but yeah, here it just goes here, and then if I go step out, it just goes. So I assume that nothing is happening, even though it's emitting this. There is no place in the code that is listening to this. I guess one thing that I can try is just put like maybe I put this dot on the initialization here, and then I listen to this event, and then I console log hello or something like that. I think I'm gonna do that now and see if I step into if it's gonna run or not before I initialize this stuff. Yeah, you can do on. Yeah, but then let's see. Maybe this is just yeah, is a dumb warning from whatever compiler or parser is doing this, because it doesn't understand that the Pixie display viewport is inheriting the event emitter class. So I'm gonna put this here to see if it's gonna console log this when the event gets emitted there, because then I think it would increases the chances that nothing is actually subscribed to that. Otherwise, it would go over the step intro, or when I step over or intro, it would go to other function. So I want to see if that happens here. I think I forgot to put the timer. And I'm still the other thing that since the last string that changed is that build space changed the date. I think that there is a chance that someone from build space saw the video and they changed the date. Not really sure, but it was gonna start on July 1st, and now it's gonna start on August 5th, which gives me a lot more time. So I think what I'm gonna do is just try to recreate Pixie from scratch, and just like I'm gonna copy as many systems they have and as much stuff that they're using to create the animation, and I'm gonna try to create everything with my own code, just copying as much stuff as possible, because that way it's gonna allow me to if I manage to do that, then I think I'm not gonna use PixiJS anymore, and I'm just gonna, because I think that if I write my own code, it's gonna be a lot easier to understand what's going on, and I'm not gonna have to do things the way that they are doing here, because it's gonna be like for a very specific use case, which is my this stuff that I'm trying to build. So like the downside for me is that I lose the flexibility that they have, but then the upside is a lot better, because then I'm gonna have the stuff that is customized for what I'm trying to do. But obviously it's gonna be very difficult to do that. That's the problem. There's a lot of stuff that goes on here when it's initializing all the systems and these classes, and it's very difficult to understand how it actually draws this stuff on the canvas. I think, for example, this events, like the way that events works, I think highlights this, is that like, the main reason I see for having something like this is that you wanna like keep flexibility for the people that are gonna use the library, because everyone's gonna have their own use case. So you create something that is like a manager of all the possible events that is gonna happen, and then you route all the events through that manager. But if you're building your own stuff, which is going to be very specific to the thing that you're trying to do, you don't need to do that. You can just set up the structure that is going to actually contain the events directly. And then it becomes a lot easier to understand what's going on, I think. But maybe not. Maybe I'm wrong. Oh fuck. I want to just tap into this, because I think this is the function that is gonna start the animation loop, or set up the animation loop. I don't remember really well. And now it's true. Whatever. I'm just gonna run this stuff until it gets to the point where everything is set up already. I'm gonna have to remove this debugger as well. This is another thing that makes this challenging, is that I can't really put the debugger inside of any updates or inside of anything that is part of the rendering cycle, because then it gets stuck on the loop and you can never like stop to or trigger the events to see what happens. Yeah, so here, for example, if I click here, it's not gonna set up everything, so I have to disable all the events that happens, all the breakpoints that are like in the middle of the update functions. Well, I guess I can test now if the stuff is gonna trigger the thing there. Yeah, so it doesn't show. So even though I'm setting it up here, or maybe it is, but like the developer tools debugger doesn't go there on the function. That's the problem. So there might be a bunch of different points on the application that is listening to this, but there's no way for me to see. Yeah, so it is calling that, but it doesn't show. Fuck's up. Yeah, it's just an empty. And now obviously what I can do is the other thing. I'll go here and then I see if it's gonna show there. If this works, I think I'm just gonna do this several different times with all the events that get emitted there. I think I wrote down all of them somewhere here. Maybe I didn't save, but I remember, yeah, I think it was this here. Okay, so it does work. Interesting. So that means that there isn't anything listening to the events there. So this is the stuff that is kind of weird to me, because why do they put the events here like this if there's nothing listening to it? And there isn't anything that explains, as far as I know, on the documentation why this stuff is done the way that it is here. But maybe because I don't remember really well if I read the... Because I might be confusing the two things. I remember reading the documentation for PixiJS several different times and I didn't find, but maybe I didn't read the Pixie viewport one. Maybe there is something explaining this, but I think it's hard to... Probably doesn't have anything. It only has this documentation here, which is just the function declarations. So I think this is the thing. I think my intuition, like the stuff that I was saying there before, is correct. Is that if I wasn't using React Pixie, then there wouldn't be any point of connection between the viewport and the stage. But because I'm using React Pixie, it automatically connects the two of them through the custom reconciler by adding the children of the stage as with this function here to that create element, or through pen child function. And then after it does that, it's gonna do the stuff that I talked about, where when it changes the view, when it changes the scale of the viewport, it's like changing the container that is gonna contain all of the other stuff from the application. Because the viewport is gonna be, the other stuff is gonna be a child of the viewport. But maybe that's the reason why on the other one is not having the zoom effect, because like you can have the main parent, which is the stage, which is going to be a container, and then you can have multiple different children. It doesn't necessarily need to be a hierarchy. So I think what might be happening is that viewport is just on the same level as the other containers are. So when the viewport gets updated, the other ones don't get updated because they are not inside of the viewport. And this is the reason why the zoom effect is not working on the other application. And it was working when I was using Matter.js, because on Matter.js, the way that I did the stuff was by adding the components as children of the other components. And with Wrapper.js, the way that I'm doing is just calling a function. So it's not like I'm directly placing the elements as children of in the React hierarchy. I'm placing them as direct childs of the stage, not of the viewport. So I think that might be what's going on here. Is it worth it to open the other one? It's kind of annoying because I don't wanna, like, it's just gonna be a bunch of refactoring and then trying to get it right, but then maybe it's worth it to know if that's the case or not. I think it's pretty likely that this is the case. Maybe, I think what I'm gonna do is just test the other events here for now. I'm just gonna put here, I'm not gonna change the function there. But I think nothing is happening through this emit, so all of the logic that actually changes the view is on the functions themselves of the plugins there, of the classes and the updates. And that's everything that they do to change the view. So like the events on the event system themselves don't do anything to the view. They only do something if you specify inside of a function. So when you don't put Pixie viewport, it doesn't change anything. It just sets up the events. I think that the event system just does the stuff that I said before, which is like this manager. It creates the manager. I don't remember. Yeah, here. It's kind of like this, but for the events, it just creates this manager. And then what is actually gonna make the view change or not is gonna be whatever listeners you attach to the event system. And the event system uses the event boundary to map the events and to go over all of the events that are connected and see if the elements got hit or not, and then decides like what is going to be triggered based on the event that happened. So it makes more sense to me that the logic that actually determines how the stuff is, how the view is going to change is on the Pixie viewport classes. And it seems like it is a lot simpler than I thought it would be, but maybe I don't understand really well how it works. Because if it is just the logic that is happening here, just multiplying or adding by the scale based on the properties of the event. The challenge is like the synchronization of that with the physics engine, because it's kind of confusing to understand. Because on the physics engine, at least with Rapier, I think with Matter.js it's pretty much the same. You create the simulation forces in the beginning, and then based on the initial state of the physics engine, it's going to determine through the step how it recalculates everything. So you have to set up everything on the beginning of the simulation, all the forces and everything that's going to happen, and then as the animation is going, it's going to calculate whatever happens through the step. So like the physics is not directly correlated with what's actually being drawn on the scene. You have to manually synchronize them. And this is the stuff that I think is challenging, because then like it doesn't make a lot of sense, because if you change the X and Y of the elements on the scene, then you have to reinitialize the physics engine every time there is an event. It doesn't seem like that is... and I couldn't find anything that talks about this. But I guess you can just change the properties of the bodies that change. I think I can actually do that as well. On the other project, I think I stopped. I didn't see if it works or not, but I follow a tutorial and then I put the template of what I think should be the logic to perform the drag events on the elements, but I didn't test to see if it works or not. I think that I'm gonna have to change a bunch of stuff to see if it works. So maybe it's not the best to try to work with the other project now. Maybe it's better to leave that for some other time. Yeah, there's nothing. Pretty sure all of them are gonna be nothing. I could do all of them at the same time, but it doesn't matter that much. Just gonna see if they're... And the events also have this zoomed, moved wheel starts. I think I'll check these ones first. Maybe I'll do all of them. Because these ones are more interesting to see if they are doing, because I think these ones are more important, because that's directly connected with the logic that runs when the event triggers. Yes, so if it is if all it's doing is this logic here that's doing the zoom, then it's very easy. But yeah, I think that the only thing that you have to do to synchronize them is just as you change here the position of the container, you also change. But this is the issue, is that I guess that's the tricky thing that is difficult to understand, because the container contains all the other elements. So when you change the scale, the x and y here, how does that changes everything else? So first I'm gonna see if the events are connected to anything. Then I'm gonna put a debugger on the class. The problem is that you can't really put the debugger, like I said before, on the update, because then it's just gonna break the thing on the cycle, and then you can't really trigger the event. So the only place that I can put is on the actual function of the class, the wheel class. That is the plugin that is gonna handle the wheel event. So I'm gonna try to put the debugger there and then trigger the wheel event and see, step into and step over to see what are the calculations. But I need to think about a way that is gonna allow me to... It would be obviously better if I could visually see what's happening, so it might be better to just do this another time and then I work on the other application or more to see if how can I set up everything to... I keep track of the physics engine values and see if they're gonna change or not after the event. Or like think about some way that I can visually see on the animation like the distance or the difference that is happening. Maybe if I could create a static object, like I can create a wall on the physics simulation, and then I put the wall at a certain position, and then I just update the drawing. So I put the zoom and the other stuff, and I attach them directly through the viewport. I think that's what I'm gonna do, actually. And then that's gonna allow me to see, because then it's gonna be very clear that the drawing is gonna be updated through the event, but then I'm gonna see like if the collision, where the collision happens, I think. But that's gonna be very annoying to do, I think. It's not very difficult, it's just a pain in the ass to refactor everything and think about it, how to pass the stuff as an argument and how to set up everything. I think first I have to see if the theory that I have is correct, but I think it is. I think the reason why the other one, the zoom event's not working, is because the viewport is connected directly through the stage, and the other elements of the application are also directly connected to the stage. But on the previous example that I had, because I was setting everything up based on the hierarchy of the React, the custom reconciler was automatically creating the hierarchy inside of the stage, and the elements on the application were childs of the viewports on that example, and that's why it was working on that case, but not working now. But obviously I can easily see that by directly putting something, but yeah. Like on the other application, I think what I'm gonna do is just create another container and then directly put that container to the viewports and then redraw the container, because the other component is obviously the x and y coordinates. Like I can just see that by the graph that I have here, the graphics. Because I think that the graphics are not going to change regardless, because there's no X and Y position, so even if the positions got updated, it's still going to draw the circle at the same point, I think. And the annoying part about testing this stuff is that I'm going to have to change the components there to receive the viewport as a props, or I think, yeah, maybe I can use context as well, but I don't really know because of the custom reconciler, so the other option is obviously to create the graphics inside of this function here, and then append to the stage. Like you can initialize here maybe as a global variable, but then there might be some stuff about React because it's a global variable, and I call this bullshit. It makes it harder to test if this if I'm thinking correctly about this or not. Maybe it does change the thing here. I think I'm putting these components as a child of the world component. So I don't think it should. It's not gonna change because then it would work. That was correct because it's already a child of the Pixie viewport component. So I think that it has to be dependent on X and Y positions, and the only way to do that is to use a physics engine, and then it's gonna be a lot more work. So here is where it initializes the zooming. So zoom is gonna be triggered here in the first place. So it first triggers the wheel here, and then after that it updates the position on the update function, because this is moving is gonna be the object there. So it's gonna run this logic here, and then I'm gonna put this. Now, obviously, the other thing that I can do is just change these functions here, see what happens on the visualization. But I think I first need to set up everything with the physics engine, because then I'm gonna have X and Y positions that I can change. or just see if they're going to change or not based on these events here on the other application. It's very... The other thing that makes this very confusing is this coordinates, because you have several different coordinates. You have the coordinates of the canvas, the coordinates of the whole website, I think. Then the coordinates of the stage, the coordinates of each element. So it becomes very confusing to know everything that is happening. Oh, so this one has, well, I guess is the function on the input manager. Interesting. Oh, it's on the decelerate DS. Interesting. So probably each one of them is gonna have a connection to these events. I think that the zoomed is gonna have something inside of the zoom. I'm just gonna go over this again. The other thing that is confusing to understand is that how exactly is using all the systems during the rendering cycle. Because some of the systems I understand because they're set up in the beginning there to accept everything up on the canvas, but then like each time that it draws something, like I couldn't find a way to just step over or step into the animation cycle and see like what exactly are all the systems that are being used to draw stuff. And I think that the only way I'm gonna actually be able to see that is if I have like more things drawn on the canvas, because like I can go when I step into or step over this part here, it just like this is a class which is the container class or the graphics class, and then inside of the class is gonna have all these methods here, and then the methods they do draw the stuff on the canvas, but they don't use any of the other systems that like, and there's a bunch of different systems that Pixie initializes in the beginning. So I think that as it's initializing everything, but the thing is that it doesn't call, the only two functions that it calls in the beginning are the init functions, the context change functions. And there are several different systems and they have a lot more functions. So because obviously not obviously, but to set up the visualization with WebGL, you have to set up the fragments and vertex buffers, or yeah, the stuff that is gonna determine the program of WebGL, which is gonna determine how stuff is gonna be drawn into the screen. And then there are some classes there that I step into that they initialize programs, and it's called, I think, state 2D, something like that. That initializes the vertex and the fragment shaders and initializes the program. And then there are some classes as well that initialize the texture and the other stuff related to WebGL. But I couldn't see any point that it actually is calling this, explicitly calling the functions or like setting. It's hard to visualize what's everything, how is everything involved into creating the drawing. Because obviously I want to extract only the stuff that is going to be necessary to create the stuff on my own. But I think what I can do is just see if, like, from the beginning, and then see, like, try to make it from the beginning, from scratch, and then just like copy or get as many classes as possible, or get all the classes from PixiJS, put them on a file, and then see like forget about the way that Pixie does it and then try to build the visualization from scratch, and then only keep the classes that I actually use to build the visualization. Because the feeling that I have is that a lot of this stuff is useless for the stuff that I'm trying to do. So it gets a lot more confusing and it's not necessary. So, but at the same time, like it is very complex because of the whole coordinates stuff and everything that is involved to create the drawing. So it's hard to know like what exactly am I gonna need, and it will be good to keep the same. And if I want to keep stuff the same, then how can I make it so that this stuff gets integrated without having to add all the other stuff? Because obviously, if I'm gonna do this with my own from scratch, then I don't think that I'm gonna try my best to not use the runners and the systems thing, because I think it makes it very confusing. So I'm gonna try to just use the classes and then do like normal imports and then just call the stuff that I think is necessary to run. And the other thing that is also like it makes it more confusing, but it's they kind of have to do it this way, is the ticker. Because obviously I think it's a good thing that, like from their point of view, is good because it allows people to have more flexibility, because set up any tickers you want, but then it makes more confusing as well to understand what's going on. So for my use case, I think it would be better if I just create like a normal, the simplest version of that as I possibly can. But maybe that part is okay to be that way. It's just annoying because of the linked lists, and I find it very challenging to understand linked lists and how they're gonna change. So. So this one doesn't have anything interesting. Yeah, so this is on the event system. So the native event is the event that actually happens. I think the event is the Pixie one. I don't understand though, like why. I think the reason why they do it like this is because probably on the other parts of the application, it uses this terminology here, let's say, to set up the other stuff. But it's actually not changing anything. It's just like changing the way you access the properties. I don't understand, like, because they could make the event from Pixie to have the same properties, I think, as the, but maybe not. And this is the stuff. So like for each event, is gonna have this class here, which initializes in the beginning there. And that's the class that contains, I think, all the calculations that are gonna happen in the scene. So yeah, these ones here, root pointer event and root wheel event, and then it maps the event that happened through these classes here, and then it uses these classes to do the calculations, I think. There's some parts that are very annoying though, because it's gonna call a function recursively, and then it gets very confusing because if you're stepping into the functions, there's a bunch of nested different functions happening. It becomes very hard to keep track of what's happening. I think what these calculations here are doing is just getting the relative position of the point based on the canvas width and height, and the rectangle, which is I think is the viewport. So I think in the beginning it creates the viewport attribute of either the view or the canvas or something like that, and it creates a rectangle class that's gonna contain the viewport, and that's the stuff that actually renders the visualization. And then it has the DOM element, which is the canvas. So yeah, we have the actual width and height of the canvas, and then we have the properties of the rectangle, which is the class that is used to draw this stuff on the canvas. And then it does this calculation here to get the relative position of where the event happened in relationship to the canvas and the rectangle, I think. So it creates this rectangle here, which is based on the canvas. So it's a map. This is the base class of all the events, I think, and then the other ones are customized. So like it's kind of like creating an abstract class where it's going to serve as a template for all types of events, the base class, and then the other ones build on top of that to specialize to what the event's actually going to be. I think I'm going to remove the camera. It's hard to know like how is this stuff connected, because like I said before, I couldn't find a way to visualize what like everything that is happening during the rendering cycle, because if you step over just the update cycle of the function, the request animation frame, and then the ticker functions that are going to run, and they don't call any system directly. I think that like it's only gonna use the systems depending on what stuff you draw on the animation. So the stuff that I have now, I couldn't figure out. The managers think is going to be the event boundary, yeah. And this, I assume that these are all the positions that can exist, like the stuff that I was talking about before. We have the screen, the global, the offsets, the place where the canvas is, I think. The client, I'm not really sure what it is. I don't understand really well why it calls this function here as well. So the event that is passing the from, I think, is the original event, the root will event, and then it creates this other one here and puts this into the map, and now it's mapping the properties again from one event to the other. Blah blah blah. Yeah, this is the function that is going to start getting annoying. I think is inside of this one, because I think what this function does is, like the name says, it goes over all the elements on the scene, and then it tries to see if the position hits any object. But it's very annoying because then there's a bunch of different functions that happen. So it gets this one because it doesn't have this use move here, and then it calls that, passing these properties here. This is the container. So I assume this is the stage, probably, since it has these children. I think this is the stage. And the event mode, I think is set up automatically, maybe. If you don't specify, it's just auto. MP location, not sure. Yeah, now this function gets annoying. It's gonna call a bunch of different functions. I think I'm gonna be able to understand much better after I set up the other project. I think that's gonna be, because that's gonna probably the best way is just to do a bunch of different tests to change the stuff on the high level and see how it changes the visualization and the physics, instead of trying to go over the source code first, because that's gonna allow me to like understand what exactly. Want to be able to see everything that is involved with the event directly, all the classes that happen. What is the graphics pipeline that PixiJS uses, and just stepping over is not like I couldn't really understand very well, like exactly what is exactly necessary to build everything that is gonna happen. And it feels like a bunch of stuff is not necessary. From the library standpoint, it makes sense that they do it like this, but for my case, it seems like it is not necessary. There's a bunch of stuff that just makes it harder to understand. And it doesn't give anything necessarily, so. so this is the viewport. So yeah, I assume that what's happening is just gonna go over the children, and then it's gonna see. So it looks like it does hit, obviously, so it passes the test, because so I think when it creates the display object, it creates this hit area property, which is going to be the size of the object. And then based on the position of the X and Y of the event, it's going to see if it is on this point or not. If it hit the element. And then it does this stuff. And the world transforms a matrix. So I think here it's just doing this calculation to see if it's gonna check if it hits the element or not, and then it returns true if it does. They're just getting the positions of the display object, and then it's gonna see contains, so it passes, and then so this is the stuff that checks to see if the point is inside of the object. Then returns true, which means that it hits, I think, or maybe not. Maybe it's the other way around. I'm not sure if I really understand what is going on here. I think I roughly understand, but not really. I think this probably calculates or sees what stuff was hit. In this case, the viewport, maybe. Yeah, so this becomes the target. So I think it does a bunch of... It goes over all those functions to see what was hit, what element was hit, and then returns that. And then this is going to be the one that triggers the event on the Pixie viewport, I think, dispatch event. And then after that, it's going to free the event. This propagates. Oh, this one is kind of annoying as well, remember? So all these functions, I don't understand really well how they work. but I think it's like similar to the bubbling stuff that normally happens with the events. But there do some custom functions to decide like how it's gonna impact the other stuff, the other elements on the scene. This is the stuff that I was talking about that changes the name, or that creates a different name here based on the event. The type is wheel, then it's gonna do this transformation. I don't understand really well why it does that. I think it's just the reason why it does that is just because like the event system sets up custom events. And this is the other thing that is kind of I guess I can ask ChatGPT this because I don't really understand very well. Like I guess I kind of understand, but because when you use event emitter, you can put custom event names, and then the way that it works is you set up the custom event name, and the only stuff that is gonna run is the stuff that you set up yourself to listen to that event. But I don't understand here. Like I think that here it's setting up normal events because they are automatically triggered if you touch the canvas. But not really sure. So I think the reason why it does that is because it sets up some events on the beginning on the canvas, but then the way that other events are, the other parts of the application are expected to listen to the events is with a different name. So like this is kind of converting to the standard name that the event would have if you set up on a normal application without using event emitter, for example. I think that's the reason why it changes here. So in the actual event system is one name, is like using pointer down, pointer this, but on here you're supposed to use mouse, I think. So instead of pointer down, it's mouse down, but I'm not really sure. It's not gonna have here, it's part of the federator events. I think on those functions it determines which one is the target, and then it accesses that there. Oh, weird. So it doesn't. I don't know why we didn't call the wheel events there. I guess it's because the wheel is different because it's directly connected. So it's a different thing. Maybe that's the difference, is that because these events are connected to the view part, what gets triggered first is the event system. Oh, but in any case, it's going to be the event system that gets triggered first. But I think that it, like, because these events here are directly connected to the container, which is part of the stage, it's inside of the stage, then inside of those functions, the dispatch is gonna see that there are these listeners here on the container when it's going over that function for propagating the events. I think that's the difference. It's gonna find these events here and it's gonna go directly to the functions that are set up here. But because this one is directly connected to the canvas and not to the container, then it first checks to see if there are any listeners on the event system, and then if there aren't, then it goes to the next event, which was set up here. I think that's the main difference. So probably the wheel is set up directly on the canvas because it doesn't need customization. And the point event is not because it needs to be translated into that point class there or something like that. But both of them have the root pointer event, which is the class there. The wheel event also has a class on the event boundary here. So I'm not really sure like why they are not set up in the same way. It's here. Yeah, this one has this one, and this has this. Oh, so it creates the point here. It's gonna be the same class. Map position to points. So this is the function that it gets called anyway if you set up through the event boundary, because this function is set up on the event boundary class in the beginning there. So the only difference is that here it calls this manually, but it's the same function that was called before there. And points. Yeah, so these calculations are done on the display object, which is inherited. So the viewport class inherits container class, which inherits the display object class. And those calculations that are from those functions are from the display object class. And I guess the new position, I think, which creates this pointer class, this point class with these positions. It's very confusing. Yeah, here it doesn't change anything directly. It's just another thing that I don't understand very well. Yeah, so those are the calculations, I think. I think all that matters for the wheel event is these calculations here. Change the positions. And they are stored on the display object through these attributes and these classes. These classes change the attributes. I'm gonna think about it. So I'm gonna see off stream this one. What events are what is, yeah. I think that was an empty list. I think I just saw. Probably an empty list, so nothing happens when it meets this event here. But I think this is probably the calculation that happens here, or the change that happens. So it goes over all those functions from the display object and then calculates the difference in position based on the event. And this probably translates the coordinates, that it gets the correct position based on the relative coordinates. This transform class is initialized inside of the display object, I think. Either the display or container is a property of those classes. And WebGL, I think, I'm not really sure. Like, I think that Pixie doesn't have everything that is necessary to render 3D graphics. It just specialized on 2D, but I'm not 100% sure. But on the WebGL, if you're going to do the 3D visualizations, you need the model view projection, which are 3 different matrices that determine how everything is going to be rendered. I'm not really sure, I don't know very well how it works, but I know that it depends on those 3 matrices. And I think that, I assume that here is going to be very similar, where these classes contain like all these matrices, and these matrices determine what's going to be rendered on the screen. They are the stuff that calculates everything. And then the shaders, the fragment, I think, and uniform. I think uniform is just a way to put variables on the program, WebGL program. Don't remember really well, but those things are the things that determine the contrast, I think, or the color of stuff. But I have to study a lot more to understand. I think I'm gonna understand a lot more once I set up the other project. I think what I'm gonna do is just try to do some experiments with the other project, with the physics engine as well, to see if I understand better. And after I'm able to implement the events using Pixie viewport and change the physics visualization, synchronize both, then I'm gonna try to build the project from scratch without using Pixie. Because I think that's gonna be harder than just making the events work, because obviously they do a bunch of work for you, the library, through all these functions and classes. So I think building my own stuff from scratch is gonna be harder, but it's gonna force me to understand how it works. I want to see where it stops. So here it changed the position of the parent based on the point and the new point. So this was the old point, and this is the new one. Like the positions. And this is inside of the wheel class that is inside of the plugin manager, or the plugin manager. So those are the calculations here. So the challenge is to understand like how is the physics engine related to this, because I assume the X and Y is going to be the same for both, obviously. If you initialize both in the beginning, initialize the physics engine and then initialize the visualization on top of the physics engine, like using the same X, Y. So here, I think that the only thing that I have to do probably is to get the past whatever. Yeah, but that's the problem, because I have to update all of the objects. That's the issue. Like I have to update everything that happens on the simulation, because it's gonna change the size of everything. So this is the, but I'm not really sure if it changes automatically though. But it doesn't make sense that it would, because like just changing the, yeah, but it should change the position. It shouldn't change anything related to the physics, but it should change the position of everything. Because if you don't change manually the position of the physics engine, then the physics is gonna be the same, but then the position of everything is gonna be off. So the collisions are gonna be off. But then how do you update everything? I think that maybe you don't need to, maybe it's gonna be synchronized, because yeah, maybe the only problem that I was having there is that the viewport is not on the same level. Like the elements that I'm rendering are not inside of the viewport container, and that's why they were not updating correctly. Because now that I think about it, like all these functions from the event system should update everything for you automatically, as is doing the traversal there, to see if it's gonna bubble up or not, or like whatever is happening during the functions of the event system when it's going over the child or the children. I think those calculations should update the positions of everything automatically if the event happened on the container that contains other elements in the visualization. I think the Pixie should do everything for you. So if it does change the position, then it shouldn't be a problem, because then, yeah, but then the question is the physics engine gonna be updated? Because it's two different things. That's the problem. Yeah, I think what I'm probably gonna have to do is just copy all the functions from the event system in Pixie, and then just apply the same algorithms but for the physics engine instead. So as it traverses the elements of the inside of the container, not only has to change the positions, yeah, but then, because this is the thing, because if it changes the position of the elements, but then the physics engine is not gonna know that the position's changed. I guess maybe it depends on the way that you set up in the beginning, because if you set up the positions of the elements based on the positions of the engine, of the objects that get created through the physics engine, then you might change the physics engine automatically. But if you set up the other way around, then it doesn't change. Let me see here. I think I'm not gonna do typing and the Rust thing. I'm just gonna, I think I'm gonna stop soon. I don't know, it's gonna be very annoying to change this stuff on this project here to make it work, or to test the stuff that I'm thinking about. This is the thing here, is that yeah, I create the graphics through this function. So this, I call this in the beginning, create the graphics here. And this is another function. So yeah, the way that I'm drawing here is based on the physics body. That's the thing. So the nodes are these nodes here that are created through the simulation, the physics engine simulation. So the X and Y position are going to be the positions of the physics engine. But then this is the thing, because the event, I think, is going to change the X and Y from the graphics, and the objects of the physics are not going to know that the positions are updated of the visualization. So like the drawing is going to be incorrect because the drawing is based on the physics, but the state inside of from Pixie perspective is going to be, the objects are going to be on other positions, maybe. So the collisions are going to be fucked up, but I'm not really sure. I think I'm going to test this another day. So I think I'm going to try to set up everything on this project here to do a bunch of experiments, and then I can see like what happens. The first thing that I'm going to test is if I append this stuff here instead of appending to the stage, like I'm doing now. I'm going to append to the... Yeah, I'm appending to this container, which is appended to the stage. I'm going to append everything to the viewport instead and see if it changes anything, if the zoom event works or not. But I think I'm going to do this stuff off stream, and then later on I'm going to try to set up everything up to do experiments. To see... Yeah, the first thing that I'm going to try to do is synchronize the events with the physics engine. And once I do that, then I think I'm going to try to deconstruct everything from PixiJS and build visualizations from scratch on another project that I'm going to do here from... without using any libraries, just try to copy as much stuff from Pixie as possible. Build everything like with my own code. I think this one. So yeah, so not sure when I'm gonna come back, but this is what I'm gonna do